In this course, we're going to learn how to use a library in Python called Keras to learn how to build deep learning models. Deep learning has certainly received a lot of press and hype, and it all may be warranted. Regardless of their application, deep learning models have been outperforming just about every other known kind of model. Keras is a minimalist Python library for deep learning that can run on top of Theano and TensorFlow. We'll define what Theano and TensorFlow are in the course. In this course, we're going to focus on building deep learning predictive models. Now, predictive modeling is a subfield of machine learning that focuses on building models that make accurate predictions. We are on the verge of an explosion in predictive analytics, and Python is emerging as the language of choice for educational and applied predictive modeling. In the course, we're going to focus on the library called Keras. A library is just a bunch of code that's separate from the core language we can import to extend the functionality of the language, and our language is Python. In the course, we're going to build an end-to-end model and explain every line of code. An end-to-end model means we're going to cover every aspect from importing our data to building the model to determining the accuracy of a model. We're going to cover the vernacular of deep learning at a very high level. By the end of the course, you'll know what a neural network is, and more importantly, you'll know how to build one using Keras. In the course, we're going to skip over the math and focus on the model building process. We don't need to know how the algorithms are written in order to build highly accurate models. We need to learn how to model and master the well-documented Keras library that will help us craft highly accurate real-world deep learning predictive models. Thanks for your interest in a general introduction to deep learning using Keras, and we'll see you in the course.
All right, in this lesson, let's figure out what our goals are. What are we trying to accomplish in the course? The course title is A General Introduction to Deep Learning Using Keras. So the first thing we know is that we're going to build predictive deep learning models in something called Keras. All right, so what's Keras? Keras is a high-level library in Python used to build deep neural networks. Great. What's high level and what's a neural network? High level just means it's closer to our language than machine language. Thus, it's easier to understand and use. All right, what about a neural network? In machine learning, an artificial neuron is an entity modeled after a real biological neuron. We assemble a bunch of these artificial neurons in order to build a neural network. All right, so why do we do that? Because deep learning, or neural networks, have been outperforming everything in their path. When Google suddenly starts dumping all of their existing models for deep learning models, it's time to pay attention. In this course, we're going to learn the basics of the artificial neuron and how they are woven together in order to create a neural network. At the end of the course, you're going to be able to define what deep learning is and be able to create a simple real-world deep learning model. We're going to focus on the vernacular of deep learning and the pieces that need to fit together in order to create an artificial neural network. We're going to skip the math for now and focus on the model building process. Building deep learning models isn't difficult, but there are a lot of moving parts and there are a lot of new concepts that require attention to detail. So, in the course, we're going to use a library in Python called Keras to create a deep learning model. Additionally, we're going to cover a lot of new terminology that's specific to deep learning. All right, let's get started.
All right, in this lesson, let's talk about defining what deep learning is. But before we can define what deep learning is, we need a little bit of vernacular, all right? So here is an Excel spreadsheet. And by and large, if you can get your data into the form of an Excel spreadsheet, then we can do deep learning on it. So if you're coming from the relational world, which I was, the nomenclature is a little tricky. For example, they don't call rows rows. You and I would call that a row. Well, because that's what it is in database speak. They call it an observation. All right. So when you hear observation, think row. Down here at the bottom, we have this thing called a target variable. Well, what's that? It's this column here, well, this entire column, that we are trying to predict. This is our target variable. We're trying to predict whether an individual will buy a bike, 1, or won't buy a bike, 0. And we're trying to do it with all that data. All that data, right, in the yellow is called training data. Over here, these columns, right, are called features, right? Now, not all of them together, each one. So the marital status itself is a feature, gender is a feature. All right, you get the idea. All right, let's talk about a neural network. So if you were to type into Google neural network, this thing right here is what you'd see. This is a very shallow, actually one layer, because we have one layer here, neural network. So what is all this stuff? All right, so on this side we have the input, right? Well, what is an input? Input is simply data, right? You'll see this a lot. X1, X2, X3, right? So the X on any input simply means data, right? We're putting some data in here. So this would be over here, we have X1, right? This would be X2, and this would be X3. It is simply data. All right, so what kind of data? Well, why do I have this 35 here? Male, 49,000. What are these? So you and I speak text. Machines don't speak text. They speak numbers. So we need to get our data into a numerical format. Here we have it into a numerical format. However, it's not normalized, and we'll talk about normalize later, but this next step here normalizes it, right? Here we have text, right? We can't, no can do, right? So we've got to turn that text into a number. Well, male or female, right? Male is equal to 1, so there's our 1. Female is equal to, so sad looking F, isn't it? 0. Right? How about 49,000? Right? That's a number, but it's too large. So what we need to do is get our data in a certain range. And again, we'll talk about why later, but for now, let's just go with it needs to be in a range, and this is outside the range. Right? So we're going to tone this thing down, this range, to a 4.9. So that's what all this is. So all this is, right, this whole thing, we were to circle this. Ooh, that is a horrific circle. All right, that's our input. Okay, that's our data. So we need to input some data into our neural network. This thing here, he does the work, right? This is, all right, I love this word. This is called a perceptron. I mean, it sounds like Optimus Prime, doesn't it? These are perceptrons. Another name for these is artificial neuron, right? Those two are synonymous. The output, well, the output is all of this, all these numbers calculated and added up to make a prediction. All right, so here it says we've got an output, again, it's numerical. We'll call it a 1, and over here on our output, on this side, 1. So if both sides say we think this person is a buyer, then we're going to output a 1. And we're going to say that this person is indeed a bike buyer. 0, not a bike buyer. 1, bike buyer. This is a neural network, right? It's a shallow neural network because we only have one hidden layer. So that's what these perceptrons or these artificial neurons are. We only have one, but in reality, we're going to have a whole lot. So one is not really deep learning. Now, this is kind of weird. So if we only have one hidden layer, right, a lot of people would say this isn't a deep neural network. If we have two, right, let's say we have and going in, and now we've got it going there. Let's say this is also a hidden layer that goes the whole way up. That's all we need are two. We do have, right, a deep neural network, in which case we are practicing deep learning. Actually, think of this whole thing, right? The whole process is one big math equation, because that really is what it is, right? We're putting data in here. It's getting crunched up here in this middle. Data gets crunched at all these different levels. Different perceptrons do different crunching, and then these guys get together and say, you know what? What do we think the output's going to be? Is that person going to buy a bike? Is it not? And then we get a final output. So many would say that deep learning can be defined as the presence of two or more hidden layers, right? And that's what these things are up here. These are hidden layers. All right?
In this lesson, let's define what predictive analytics is. Predictive analytics isn't hard to understand, at least at a very high level. Let's take a look at an example of where you use predictive analytics in your everyday life. You're at the grocery store, you're done shopping, and you're ready to check out. Your brain starts to run a built-in predictive algorithm with these parameters. The expected output. What's the fastest line? That's the one you need to pick. Target variable. The time spent in the line. The less, the better. What's the fastest way to leave the shop and go home? Historical data. Your past experience from previous shopping sessions. Predictors or features. The length of time, the number of items in the basket, the average age of the people in line. The predictive model, the one that your smart brain picks. Basically, computers do the exact same thing when they do predictive analytics or even machine learning. They copy how the brain works. Obviously, computers are more programmatic. They use well-defined mathematical and statistical methods and much more data. However, you and I do predictive analytics every single day. All right, in this lesson, let's learn about the Jupyter Notebook. The Jupyter Notebook is our IDE. An IDE is an integrated development environment. It's where we're going to write our code. How do we get there? For Windows, let's come over here and type in CMD and hit enter. And let's type in Jupyter Notebook and hit enter again. And now we're going to get the home page. It says home and it's a URL. And in order to open up a clean notebook, we come here and we come here, we navigate to Python 2 and we hit OK. And this is a cell. And this is our Jupyter Notebook. So the first thing we want to do is let's name it. So we just click on that. Actually double click. It brings up this dialog box and we'll call this our first, I was going to say Python, notebook. We'll say OK. And now we can see it's changed the name to our first Jupyter Notebook, right? So this is a cell and this is where we type our code. A nice thing about this is we can also document what we're doing. So notice here it says code. If we change this to Markdown and we come down here and let's type in, how about a pound sign to make it a nice large header. Then we'll say, let's get started. Let's get started. And Every time we want to execute a cell, we hit the control button and the enter button. And now that's run successfully. All right, now if we want to come up here and run some code, we go to the next cell. This adds a cell, and when we're highlighted here, if we don't want the cell, we just delete it. We cut it. The scissors gets rid of it. Right? Let's write some code. Let's import pandas. Pandas is a library as PD. We're going to import pandas. We're going to alias it here as PD. So all you have to type in as PD to be able to use panda. Control again, enter. It's running. You can see the little asterisks, and now it's finished. You can also run your code up here. Let's put that there and hit the enter, and it will execute and move to the next line. We can move our cells up and down. All right, so let's put our highlight there, and let's move the cell down, or move it up in that case. Let's move it down, and now we can type something else in here. Let's type in some more documentation. The import means the word import means to bring in to Python, to bring in a library into Python. All right, Shift Enter, and there we go. All right, so what are some other things we can do if we wanted to stop? We're executing some code and it's taking longer than we anticipated. We could come up here and hit the stop button. Right? We can insert. If we didn't want to add, we can highlight our cell, right, and start above or below. Right? Let's come up here and type something. Let's say backspace 1 plus 1 plus 2, 1 plus 2, and we hit Shift Enter, and it gives us the output. Now, let's say we've done this the whole way down. We've got a big long list of code, and we want to clear the output. So let's come up here to Cell, Current Cells, Clear. Current Output, Clear. And that will clear all of our cells. And I promise you'll use that later. That's really a handy feature. All right, we can save anytime you want. This is kind of like forcing a save. It will auto-save every few seconds as you're working through the code. But again, you can force a save anytime you like. All right. Let's move back to the home page for a second. We have what we can see on our home page what notebook is running, or notebooks. So let's come down here and we can see our first Jupyter notebook is running. So we can highlight on this, right? Click on it, and we can come up here and we could shut it down, turn it completely off, and we could delete it. So let's go ahead and shut it down. Let's go ahead and open it back up. And it'll open up from scratch. Let's say we did this. Let's go Control Enter. This is how you're going to execute if you don't want to continue to hit this all the time. Most people will hit Control Enter. So let's go ahead and Control Enter. And there's 3. So this looks like it's run. And if we were to shut it down, right, it may save this for us. However, if we have a whole bunch of code and we start this again, each cell will have to be run, right? Once we close this window, right, this is our Python server. We close this, it shuts everything down, right? If we come up here and we see this, just like this, it's not been run, it's not been executed. You're going to have to step through the entire process again, right? Or you can run all the cells up here if you like, right? All right, so let's recap. So these are cells, right? In cells, we can type text. We have to come up here and say markdown in order to type some text in here, right? This cell, we have code, and it says code, so we can type some code in there. We can hit Control Enter to execute. We can also hit this little button here to execute, and that'll take you to the next line, right? If we want to come up and cut a cell, we use the scissors to cut a cell. We can easily add a cell by hitting the Add Cell. And if we want to save our entire workspace and we want to force the save, it's called a checkpoint, we hit the Save button. Right? If we want to clear our screen, we come up to Cell and Current Cells, and we clear all the cells. Right? As we go through, I will show you some more hints to work with our notebook, but that really is about it. That's all we need to know to get started building our model. All right, in this lesson, let's learn how to install Python. Now here we have a Jupyter notebook, and recommend you just click on this URL, but you can't get to the Jupyter notebook without installing Python. Now Python used to not be so easy to install. However, it's now very much a click, click, click on both major operating systems, and those two are Mac and Windows. So how do we get Python? We type Python and Anaconda. And the first one we get is download Anaconda now from Continuum Analytics. And this is the page we want to navigate to in order to download our Anaconda distribution. And it really is easy as navigating down to the bottom, and we want Anaconda 4.3.1 for Windows. And you notice we have two versions. We have this 3.6 version and we have this 2.7 version. Now, most of the time, at least if you're in the Windows world, you always like to go forward. You don't like to go back. However, most of the real world models are still being built with Python 2.7. So we're going to go with Python 2.7. So download this for either Windows or download it for Mac, and I guess I did forget to mention, you can also download it for Linux. And of course, like I've mentioned a few times, we're going to download it for Windows. And it really is as easy as downloading the installer and installing it. As one of my friends says, it's a click, click, click installation. Now, the only trick is, let me close this. We need to be able to start our Python notebooks. And our Python notebooks are our development environment. All right, so in order to do that, that's a little different, right? We don't come here and then search for our applications like we're used to in Windows. We come here and we type command, CMD, and this opens to the user's West, and this is where Python is installed. Well, it won't be West for you, but it'll be users in your name, unless you change the location of the installation. And I don't recommend you do that. So the IDE, or the development environment we're going to code in, is actually a URL. And in order to get to that URL, that thing we call a Jupyter notebook, then you have to open it. And when we type Jupy, Jupyter notebook, it opens the notebook. Now, one little caveat here is that once it's opened, right, you don't want to close. Let's go back here for a second. He needs to remain open because this is the server on your laptop, right, or whatever machine you're using. This is actually running this. So if we close this down, it disconnects, right? All right, so that's how we install it. We're going to talk about the Jupyter Notebook in the next lesson. The only thing I wanted you to keep in mind was that when we do our CMD, we need to keep our Python window open. All right, we can't close it. And in order to create a new notebook, we want to come to New Notebook. See, it says here, Python Notebook, and it's going to open a Python notebook for us. And error, one created a notebook. Why is there an error? Because it looks like I shut down my command window. So let's go to the command window again. Let's type in Python. Let's type in Jupyter Notebook. Hit enter to start our server and to pull up our Python window. Now let's try it. Let's come to New and let's create our Python notebook. And this will bring up our Jupyter Notebook. Right? And this is actually our development environment. This is where we're going to type code. Right? And in the next lesson, we're going to cover this notebook in great detail.
All right, in this lecture, let's talk about importing our modules, and let's start by talking about how I laid the course out. So on certain cells, I have steps. Step 1, step 2. All right, these are where we're going to start. Now, that seems like common sense, but I just thought I would mention it. And under the steps is textual information about the step. So that is going to be about that step. And it's just information you may need when we run our cells. So in this step, we're just going to import our modules. All right. So remember, let's talk about Python. All right, here's Python, and that's the core language. So all these things that come out from Python are libraries, okay? And we can import these libraries like NumPy, like Keras, like scikit-learn into Python, right? The library comes in to the language, so we can use the stuff that's in the library inside of Python. It extends the functionality of Python, right? So in order to do that, it's really quite simple. We can import the entire library if we want, and that's how we do that. Import NumPy. This means we're bringing in the entire NumPy library into our workspace. Right? That's not really the Pythonic way, so let's look at a more focused way of doing that. So up here we have this from. From what? From Keras. Keras is the library, right? Well, from Keras do what? Bring in, I want the models, and in the layers and the models, I want you to import sequential, right? And dense. And we're going to use these to build a model. So import equals bring in. And when you use import and just the library, then you're bringing the entire library in. When you use from at the beginning, you're bringing in a module from the core library, right? Here's the core lib, the library, and we're bringing in a module. Import, sorry, import something, right? Some part of that library. So it's really straightforward and really great that no matter what we're using, whether we're using Keras or scikit-learn or NumPy, the approach to bringing in modules or bringing in libraries is identical. And that's just one of the features that makes this language, the big Python, so powerful. All right, in this lesson, let's learn how to import our data. All right, first in cell 3, we're going to set a random seed. All right, it doesn't have to be 7, it can be anything. And up here, remember, the cell above has information about the Python code that we're going to execute immediately below. And the last line, the only purpose of seeding is to make sure you get the exact same results every time, right? At this point, it doesn't matter how the seed is set, nor does it matter if we understand it. What matters is we need a random seed for reproducibility. And that really is a very straightforward interview question. What do you use a random seed for? And the answer would be for reproducibility. End of story. All right, let's move down here to step 3. All right, actually this was step 2. Sorry, it's up there. I didn't have it, but that was step 2 is setting a random seed. Let's go and import our data set. So down here we have the same syntax as we did earlier, right? There's that from, right there. From what? From this library called pandas. Import what? Import this function called read CSV. All right, what's read CSV going to do? He's going to read this function. It's going to read the contents into this variable. All right, right here, this thing is a variable. Right, it's simply an empty container for this data set. Sorry about that, we had a pen blow up. Keep in mind everything in the supervised machine learning world, the one we're going to live in, has a data set. So this is our variable. That's going to go inside there, right? And this data frame, this can be anything, Doesn't have to be data frame. It could be df. We could simply use df equals. We could use anything we wanted, right? To read this function, to read the information into the file name. So that's really all there is to it. This last line really does all the work, right? Why? Because it's a method, read CSV, and methods are usually an action verb, right? That's how I think of methods. Right? So he's importing this into file name and setting a variable of data frame that we're going to use in a minute to create our model. All right, in this lesson, let's go ahead and split out our variable and create an array to hold our data values. So the first thing we're going to do is down here at number 7. So the first thing we're going to do is create an array. An array is simply going to hold our values. It's going to hold our data frame values. All right, so what's an array? So an array in Python is this. 1, 2, 3. That's an array. Now an array in Python is not this. 1, Mike, 2. So why is this not an array? You can't have mixed data types in an array in Python, right? They must be of the same kind, and most of the time they're going to be numeric, right? They're going to be numbers, because most of the items we work with are numbers. For example, all the values in this data set are numbers, right? So the next thing we're going to do down here, this is a little tricky, this next step. And it's not tricky, it's just kind of like there's a caveat. So down here at the bottom we have this array, right? So here's our array, we've created it. Right now we're going to split it into x and y, right? So notice here we have that 0, and here we have 11. If you come up here and you would count, you would say this would be the first column, and this would be the what? The 12th column. So if we come down here and look, so why am I separating this, right? That is the array with our data set, and down here is the array for our target variable over here, right? So why do I have 11 if there are 12 columns? Well, because the 0 counts, all right? 0 counts as a 1 in an array. So up here, this isn't 1, this is 0. Now this is 1, and now if we count over here, then this is 11, which makes our target variable, let's see if I can draw this, this is probably going to be ugly, but let's try to do this. This target variable, oh, that's not bad, down here in the 11th position, right? We're setting it to y. Y is going to be our target variable, right? The rest of this, 0, right? So that 0 right here is here. It's the first column in our array. And this 11, come on 11, see how this goes. Looks like I'm shooting a rocket off. Ooh, is here. It is, oh, that is an ugly little arrow, isn't it? Let's color it in. All right, that's the 11th position, right? This is our target variable, right? TV, that's that thing we're going to predict, right? So it's not hard, right? The array, the concept of an array is not hard. Separating out our variables isn't hard. The caveat is it took me a while to realize that an array doesn't start with 1, right? Because in the relational world, the one I came from, this is really the first column and this is the second. Well, not so in a Python array. All right. All right, in this lesson, let's start our model building process in Keras. Models in Keras are defined as a sequence of layers. We create a sequential model and add layers one at a time until we're happy with the network topology. So down here we can see on our first line, this is where we define our Keras model. Model equals sequential. All right, so what does that mean? So let's come up here and draw this. Think of this as a box. This is sequential, SEQ. right? And inside here are our layers. There's the first layer. There's the second. This should probably be called lasagna instead of keras, right? So each of these is simply a layer of a neural network. All right, so the next thing we need to get right, or the next thing we need to think about, is this, input dim. So what that means is input dimensions. So in our data set, we need to tell it how many columns we have. Right? Those are the dimensions. I shouldn't say columns, I should say attributes, right? Each one is an attribute. I have to get used to the vernacular of machine learning. All right, so 11, because we have 11, I'm going to do it again. We have 11, I'm calling them columns. So we have 11 columns in our data set. And that's what we mean by dimension. All right, so we have the input dimension. That's what that is. All right, now we have to define our fully connected layers. And we define our fully connected layers with the dense class right here. So you're thinking, okay, well, that's great. What's a fully connected layer? Let's come up here and draw that. Fully connected layer, here we go. Here are our neurons, and it just means, there we go, there we go, there we go, there we go. All neurons in this feed-forward model are connected to one another, right? There are no gaps. That's simply what that means. We can specify the number of neurons in the layer in the first argument. So here, in our first input layer, we have how many? 11 neurons. Here we have 8, another 8, and the output is 1. Why? Because in the output, we've got a 1 under 0, right? That's it. It can only be one of those two. It's a binary classification problem. The initialization method is a little more complicated. In this case, we initialize the network weights to a small random number generated from a uniform distribution. That's why we call it uniform. In the case, it'll be between 0 and for now, that's great because that is the default uniform weight in Keras. Lastly, we have this thing called an activation function. And here we're going to use the ReLU activation function, which is short for rectifier activation function. We're going to do that on the first 3 layers. You can see we've got it there, we've got it there, and we have it there. Here we have a different function. It's called a sigmoid function. And we use the sigmoid function to ensure that our output is a 0 or a 1. Activation functions are really beyond the scope of this course. You'll find ReLU being used often except for the output. So activation functions are strange. Activation functions just simply mean within the network model, are we going to fire? Right? So here we've got these things. We've got this and this, right? We'll call this the act for the activation function. So he sees the data here, right? And either there, and he says, do I fire or do I not fire? All right? Now, obviously, it's a little more complicated than that, but that's kind of the gist of it. And that's it. We've built a how many layer model? You can see here. 1, 2, 3, 4. A 4-layer model. Now up here I have a question. How many layers are hidden layers in our model? All right, so you tell me. Well, the input layer, right, this first one, is not hidden because it's an input. The output layer is not hidden because it's an output layer. So we really only have 2. All right, so we have 2 hidden layers. That's our answer. Another good question might be, if we look at this, is this considered technically a deep learning model? Well, yeah, because it has two, right, hidden layers. Here are our inputs, here are our hidden layers, and here is our output, all right? All that, I'm not going to go through and draw all that, but you get the idea. All right, so yeah, this is a deep learning model. All right, in this lesson, let's go ahead and compile our model. All right, we're getting down to the end here. Step 5, compile the model. After we define our model, it's time to compile it. Compiling the model uses numerical libraries under the hood. We call that the backend, such as Theano and TensorFlow. And in a minute, when we walk through the entire process, you're going to see Theano being used. The backend automatically chooses the best way to represent the network for training and making the predictions to run on your hardware. When compiling, you must specify additional properties required when training the network. Remember that training the network simply means finding the best set of weights to make predictions for the problem. We must specify the loss function used to evaluate a set of weights. The optimizer uses this to search through different weights for the network and any other optional metrics we would like to collect during the training part. In our case, we're going to use a logarithmic loss, which for a binary classification problem is defined in Keras as binary cross entropy. Log loss quantifies the accuracy of a classifier by penalizing false classifications. So we want to minimize log loss. Minimizing log loss is basically equivalent to maximizing the accuracy of our classifier. All right, so up here, you can see that I have to find a little bit that you can read through, but it gets deep quickly. So if you want to read more, again, defining these, right, cross entropy, this is a special kind of cross entropy. Why? Because remember we said in our output, we have a 1 or a 0, right? So we're working on a binary classification problem. So this is a binary cross entropy. So that means we kind of have to define what cross entropy is. Again, beyond the scope of the course. We also use a efficient gradient descent algorithm, ATOM, and we do that because it's default. Again, the specifics of ATOM are outside the scope of this course. But as an optimizer, you're going to see ATOM used a lot. Metrics, so what is our metric, right? Well, we said accuracy. Remember we said log loss is equivalent to maximizing accuracy, all right? So we're going to use accuracy as the metric to define how well a model does. And accuracy is kind of the de facto way we evaluate a model. All right, so we've compiled our model up here, and now we're ready to move on to the next phase. So in this lesson, let's learn the basics of fitting our model. Now it's time to execute the model on some data. We can train or fit our model on loaded data by calling the fit function on the model. The training process will run for a fixed number of iterations through our datasets called epochs. We set this using the MB argument. You can see here it is, MB, the number of epochs. Here we're going to run it for 50. We can also set the number of instances that are evaluated before a weight update in the network is performed. This is called batch size and is set using, obviously, this batch size parameter. For our problem, we're going to run on a small number of epochs, right? 50. That's really small, actually. And a relatively small batch size, 10. Yeah, that's pretty small. Again, these can be chosen by experiment. However, since we're resource constrained, we're going to start small and try out a whole bunch of different parameters before we go big. All right, in this lesson, let's walk through our model end to end. So the first thing we have to do is import NumPy and import sequential from models and dense from layers. So Control Enter. Let's move down to the next step. We're going to set our seed. Control Enter. We're going to import our CSV. Control Enter on him. We're going to create our array. We're going to Control Enter on him. Define the X and Y of our array. Control Enter. Let's take a look at the data. Great, that's what we want. And now there's our model. So let's go ahead and Control Enter to build the model. Let's compile the model where the work's done. And let's fit the model. Now I didn't create a separate video for scoring the model because it's really straightforward. We simply create a variable called scores, and we're evaluating X and Y, and then we're printing out the metrics, right? So that's pretty straightforward, and I didn't think that last step needed its own video. So let's see where we are. All right, so we're finished. Let's go ahead and take a look at the score, and wow, it's 0.60% better than flipping a coin. That is horrific. All right, so what happened? Well, something happened with our numbers. Remember when we talked about how important it was to scale? All right, so here we've got 90,000, 60,000. Right, models don't like these here age. We've got 50, 49. These wide ranges, all right? Sometimes, specifically with neural networks, and specifically that I've seen so far with Keras, they really have a hard time with it. It really throws the model off. So all we're going to do is take this and we're going to normalize or scale it down, right? Scale simply means we're going to put it to values between, let's say, a -10 and 10, right? So I've already done that in another CSV. So let's open up that, and I think I called the CSV CN. Let's take a look. Yes, so we can see in our yearly income, instead of 90,000, I put a 9. 60,000, I put a 6. So anything in that range is 60,000. Anything in that range around 70 is 70,000. And I did the same thing with age. Now let's see what's this BBCN. And also what I did to make the model run a little faster for us was only bring in what, 400 rows? How many rows do I have? Something like that. Maybe 500. All right, so let's apply the model to BBCN. Come here. Nope, let's hide you. Where is our? So we're just going to add in. Let's go ahead and load it. And let's go ahead and take a look at the values after we put it in our array. All right. There we go. So we can see now we have our range, right? The numbers between 1 and 10, and so is the age. And that's all we've done. I'm not touching anything else. Now let's come down and run through the process of building, compiling, and fitting our model and see what happens. A little bit quicker this time, and that again was because we only have 500 rows in our data set. So here, let's take a look. There is our accuracy, right? 50.60%. Let's hit Control Enter. And that's a little different, right? 64.60%, right? Simply because we've scaled or normalized our data. All right, that's massive. And I did that just to show that neural networks are really susceptible to scaling. All right, so it really is important to scale our data before we start. Now, in the next lesson, we're going to tune this model. All right, we've got an accuracy of 6460, and we're going to do a lot better. All right, in this lesson, let's tune our model a little bit. Let's see if we can do better than the 64% we have here. So the first thing we're going to do is come up and add another layer to the network. And that is as easy in Keras as copying. Well, it's easy for me to say, huh? Control copy, space, Control V. And all we're doing here is adding another layer to this neural network. So let's go ahead and hit enter here, Control Enter. Let's move down to the process again. Control Enter. Control Enter. Let's see how we do. Let's see what the output is. 6460 is our... Oop, we did worse. So we added another layer and it didn't help us. So let's go take that layer out. The next thing we're going to do is cut down the number of neurons in our neural network. Let's call this 5. Let's call this, how about 4 and 4? Control Enter. Control Enter. Control Enter. All right, we're done. Control Enter. All right, so we're going in the wrong direction. So let's come back up to our model and let's go to, how about 12? Jack this up a little bit. Let's do 8. And now let's come down to the number of epochs. And this will surprise you. All right, we're finished. Let's see how we did. Now we're at 74%. All right, so we're climbing. All right, let's come up here to the top and let's go from 200 to 500. Will that make a difference? All right, we're finished. Let's see, did we do better than 74%? No. All right, so somewhere in there, all right, maybe around 300, we have a point where we didn't do very well. So one of the slams against neural networks is that they're finicky, that you have to do a lot of tuning in order to get them to perform well. They're kind of like a sports car. Now, to me, that's just part of the process, right? Now, if you're interested in becoming a machine learning engineer, I have a short course down in the description, down below. That's $9.99. That will provide you with some real-world advice on becoming a machine learning engineer. Thanks for watching. Subscribe, hit the little bell, and we'll see you soon.